Good morning, Doctor. We are from Engineering Mechanics, DNR 17003, Section 1. Our group project is Truss Design and Analysis for Communication Towers, and our lecturer is Hafidzuddin bin Hassan. Our group members consist of me, Mackenzie, Kirk Mingteng, Tan Po Zeng, Wan Ukail, and Venedex. So for the abstract part, in this video, we will explain about the aim of this project, a short brief about the topics of this project and the instruction of this project. After that, we will show the design of our communication tower with detailed drawing using AutoCAD software. Next, we will perform calculation on forces in each member of the tower using methods of joint and method of section. We will also make discussion about our findings and make conclusion about our project. Now let's move on to the objective. The objective is to design a 15-meter tall communication tower with a 6-meter base using AutoCAD software. Secondly, we need to determine the support reactions and forces in each member using method of section and method of joints. The last objective is to perform analysis on the communication tower to explain our findings in detail and make reflection regarding to this project. Now I will pass to Venedex to explain about the introduction.
Hi, my name is Venedex Daniel. So I will cover about the introductions. Communication tower are vital structure used to transmit wireless signal and provide internet access. By the following instruction, these towers are often built using a truss structure, which is a strong, lightweight design and made of the triangle and distributed load efficiency. In this project, we designed a 15-meter tall of the communication tower, which are 6-meter base using AutoCAD software. We analyzed the tower stability under the vertical and horizontal forces. We're using a static method such as a support reactions, method of joints, and method of sections. Our aiming is to ensure the tower is safe, stable, and structurally sound for a real-world condition.
Okay, for our group literature review, communication tower are commonly built using truss structure because they are strong, efficient, and able to distribute load evenly. Our group is the Thailand Super Titan 80 feet tower as a reference to create our own communication tower design which can withstand high load capacity and wind resistance. To determine the force in each member of the tower, we use the method of joint and method of section, which are standard technique in structural engineering. This method help ensure the tower can safely support both wind pressure and weight load such as antennas and ice. Real-world example like the Bhutan Telecom 30-meter tower are designed to withstand strong wind, speed and heavy equipment loads. A wide concrete base is also used in tower design to provide stability and prevent tipping. Overall, a safe and reliable communication tower depends on proper truss design, accurate force analysis and a strong foundation.
Okay, thank you very much, Wan. Now I will explain about our communication tower design. As you can see, we have two supports, which is a pin support and a roller support at the bottom of the tower. The tower has a width of 6 meters and height of 15 meters. We have 5 external forces. 2 of them are 1000 Newton from the top of the tower and 3 100 Newton from the right side, which act as the wind load. Now, in order to calculate the force members of the entire truss, we need to find the support reaction at the truss first. By doing that, we will find the summation of force of X component equals to 0 of the entire truss, and we will find out that AX is equal to 300 Newton. By using force in Y components equal to 0, we will find out that AY plus BY equals to 2000. By finding the total moment of joint A is equal to 0, we found out that BY is equal to 550 Newton. By substituting the value into the first equation, we will find out that AY is equal to 1450 Newton. Now, by using method of joint, we will find the force members in joint A. By summing the force in X component is equal to 0, we find out that force in member AB is equal to 300 Newton, which is in compression. By summing the force in the Y component is equal to 0, we find out that force in member AC is equal to 1450 Newton, which is in compression. Now we will use the method of joint at joint B. By summing the forces in X component is equal to 0, we find out that the force in BC is equal to 335.5 Newton, which is in tension. By summing the forces in the Y component is equal to 0, we find out that the force in member BD is equal to 700.2 Newton, which is in compression. By using the methods of section, we will find out that the total moment at joint E is equal to 0, and we can find out that the forces in DF is equal to 850 Newton, which is in compression. By using method of joint at joint D, we will find the summation of forces in the X component is equal to 0, and we will get our first equation. By finding the forces in Y component is equal to 0, we can find out that forces in DE is equal to 334.6 Newton, which is in tension. By substituting the value into the first equation, we can find out that forces in member DC is equal to 299.2 Newton, which is in compression. Now we will move on to joint C. By summing the forces in Y component is equal to 0, we find out that the forces in member CE is equal to 1300 Newton, which is in compression. By using methods of section, we will sum up the total moment at point G is equal to 0 and find out that the forces in FH is equal to 950 Newton, which is in compression. At joint F, we will sum up the forces in the Y component is equal to 0, and we find out that the forces in member FG is equal to 223.3 Newton, which is in tension. By summing the forces in X component is equal to 0, we can find out that the forces in member FE is equal to 299.7 Newton, which is in compression. Now we will move on to joint E. By summing the forces in Y component is equal to 0, we can find out that the forces in member EG is equal to 1150 Newton, which is in compression. By using methods of section, on point I, we will sum up the total moment at point I is equal to 0 and find out that the forces in HJ is equal to 1000 Newton, which is in compression. At joint H, we will sum up the total forces in Y component is equal to 0 and find out that the forces in member HI is equal to 111.7 Newton, which is in tension. By summing the forces of X component is equal to 0, we can find out that the forces in member GH is equal to 199.9 Newton, which is in compression. At joint G, we will sum up the total forces in Y component is equal to 0 and find out that the forces at member GI is equal to 1050 Newton, which is in compression. Now we will move to joint I. By summing the forces in X component is equal to 0, we can find out that the forces in IJ is equal to 99.88 Newton, which is in compression. By summing the forces in the Y component is equal to 0, we can find out that the forces in member IK is equal to 1000 Newton, which is in compression. Now we will move to point J. By summing the total forces in X component is equal to 0, we can find out that the forces in member JK is equal to 0.1342 Newton, which is in compression. By summing the total forces in Y component is equal to 0, we can find out that the forces in member JL is equal to 999.9 Newton, which is in compression. Lastly, we will move to joint K. By summing the forces in X component is equal to 0, we can find out that the last member, which is member KL, has a force of 0.12 Newton, which is in tension. And the right side of this paper shows all the members that we had calculated. Now I will pass it to my teammate Tan Po Zeng to explain about the discussion part.
Thank you, Magazine. Now I explain about the part of discussion. For the design of communication tower, we have used truss design, and we use the method of joints to find the force in members BC, BD, AB, AC, DE, and other joints to find the member forces. To find the forces in member DF, FH, and HJ, we use the method of sections to find it. These two methods can produce straightforward results. Load and wind pressure are the elements that we concern. When designing the tower, we also considered load and wind pressure as external force as they are natural force that will definitely affect the tower. We must ensure each of the member of the tower must be able to withstand those external force as they will affect the tower structural integrity and stability. And for the limitation that we have faced during the project, due to the academic schedule is too packed, our group members are also very busy with other subjects as there are many other assignments to complete. Because of that, we decided to design a more simpler tower to facilitate calculation process and produce a more straightforward result.
Thank you. I will discuss about the conclusion. In conclusion, this project successfully achieved its main objective in analyzing and designing the communication tower truths. The key of the design, parameters and engineering strategies were identified and applied to improve the tower strength, safety and performance. The result shows that the design not only worked but could help develop more reliable and efficient communication tower system. It has both academic values and practical significance, especially in improving the security and efficiencies of communication infrastructure. The recommendation presented can help guide future research and assist industry professionals. Overall, the project supports ongoing efforts to improve connectivity and communications through better tower design.
That's all from us. Thank you very much.